And all right, I think we're rolling now. All right, so section 1.1 is all about modeling and equation solving. It's kind of these two separate things. So we'll talk about the modeling side of things first, and then, like I said, we'll get into the different methods for solving some types of equations. So there are three different ways to display a model. All right, so like we talked about, we have algebraic, which essentially is building an equation. All right, and that's usually the more difficult one for people, trying to figure out how we can formulate an equation for a certain situation that we have. Another way would be graphical, which would be to draw a graph showing the relationship that you're talking about. And the third way is numerical. And that would be just looking at data in a table. All right, so what we're going to do is we're going to be kind of working our way from the bottom to the top of this list through an example. We're going to start with some data in a table, which is usually where you begin. Okay, if you're like doing an experiment or taking a survey or something like that, you're usually going to begin with some sort of data that you've collected. And then you're going to use that, see if you can construct a graph from that, and then use the graph to help you come up with an algebraic model. And usually the algebraic model is kind of the end of the road, because that algebraic model then allows you to plug numbers in and use that to kind of make some predictions and things like that down the road. So I'm going to steal an example out of your textbook here that they use at the beginning, which is something that maybe is interesting to you guys if you guys have jobs, is the minimum wage. Now the data that I have only goes up through 2005. We could include some data from today if we wanted to, if you guys know what the minimum wage is. But it might throw our data off a little bit, because it goes every 5 years up to 2005, and then it would be kind of a jump, to 2014. But we can try it maybe and just kind of see how it goes. But so here's the data we're going to use, though. So we got the years. We're going to start with 1955. And we're just going to go every 5 years. And some of you guys might be a little shocked at what the minimum wage was back in the day. So right around 1995, that's when I was your age, when I was working minimum wage. Okay. And then the minimum wage for each one of these years, this is in dollars and cents. So in 1955, the minimum wage was 75 cents an hour. And then in 1960, it was up to $1. $1.25. Bless you. $1.60. And then, yeah, in 2005, it didn't budge. So maybe we'll put a little, break at the bottom of this. So today, in 2014, anybody work a minimum wage job? Do you know what that is? Okay, well we'll do 815 then. And we're going to leave this out of our data for now, but we might plug it in later and just kind of see if it fits the pattern a little bit. Something else we're going to look at here is something that's called purchasing power. Okay, purchasing power basically represents if we got rid of inflation, okay, so what would the amount of money that we'd be able to be spending in today's dollars back in whatever year it was, okay? So basically this is kind of a way of, like if you look at 1955, 75 cents an hour, if you try to compare that to today, it's kind of hard to do because the inflation, has ballooned it up so much more than what it was. But if we kind of get rid of that, that's what the purchasing power does. So like in 1955, it'd be kind of like having a minimum wage of $4.39. Okay, so I'm going to pull that through here. And I'm not entirely sure why they did this, but the purchasing power that they used is in 1996 dollars for some reason. So it's not based off of today. So we wouldn't be. We don't know what the purchasing power is off of, the data from 2014. So we can't complete the table there, but we can play around with the minimum wage part of it anyway. Okay, so the very first thing that I want you guys to do with this is we're going to put this data into our calculator, okay, so that we can start to work with it a little bit. Okay, so to do that, you're going to go to the button that says Stat, okay, and that's, if you go to where it says Alpha, and you just go over 2 buttons, there's Stat. If you hit Stat, it's going to take you into this menu. And we want to edit. So you're just going to hit Enter. Okay, now like mine, you might have something in one of these lists, and you want to get rid of it. Okay, so here's the thing. You can use the arrows to kind of move around from one list to another. You can also go up here. Now, if you're up here, you want to be careful. If you want to get rid of a list, or you want to get rid of the data in a list, you have to hit Clear. If you hit Delete, then you actually delete the entire list, which we don't want to do. We want the list to be there, we just want it to be empty. Okay? So the Clear button is like right below all the little arrows over here. Okay? So once you're up and you've highlighted the little L2 or whatever it is, if you've got something in there, then hit Clear, and you'll notice on the bottom everything will go away. Then hit Enter, and you should have an empty list now. Yeah?
Yeah, I just pressed delete before you said that.
Okay. Hold on. Can I pause this? No. Okay. Well, I can quick fix it. Okay.
Almost done. It starts at 2.
Okay. Okay. There you go. All right. So we're going to need L1, L2, and L3 all empty. Okay. So we're going to make sure you've got that. Yeah. So what we're going to do is we'll do L1 is going to be the years, the minimum wage, and L3 power. Now, before you start typing numbers in there, in general, if you're using time or years as data, it's better to use a smaller number than the entire 4-digit number for a year, because your calculator has difficulty crunching numbers that are big. And 4 digits even sometimes can give it some problems. So what we can do is we can modify L1 to make it like years since something, if we wanted to do it that way instead. Okay, and if we just remember that, that'll work a lot better for the calculator when it's crunching the numbers later. So like for 1955, if instead of doing 1955, what do you think we could change it to that might make it a little bit easier to work with? You could click it all the way down to 1 if you wanted. What might be easier to follow if you're looking at it later, though, is to just make it a 55. Okay? So we're going to go that way with it. But that's totally fine, too. As long as you can remember that 1955 is year 1, and then every other year is that many years since then, that's fine, too. So go ahead and fill out that list just with all of the years. And so the year 2000 would have to be 100. Okay, make sure you're doing that. You're not making that 00, 0. And then 2005 would be 105. All right, and then the other ones you can just type the stuff in directly. Okay, it's just in dollars, so that's fine. Those are small numbers. So go ahead and fill out L2 with the minimum wage and L3 with the purchasing power then, just like you see it in the list. All right, so what we're going to do with this is we're going to create some graphs now from this. Okay, we're going to make a scatter plot of this data. Everybody know what a scatter plot is? Seen those before? Okay, basically it's a plot of a whole bunch of dots. And each one of these different sets of information down this list is going to be another one of those points on that scatter plot. Okay, now here's the thing though. We've got 3 columns here. Okay, and scatter plots are just x, y. Right? There's just 2 things that we're looking at together. So we're actually going to create 2 scatter plots here. One scatter plot is going to be the minimum wage with the time, and the other scatter plot is going to be the purchasing power with time. Okay? And we're going to look at both of those and see if we can answer some questions about minimum wage and purchasing power by looking at those graphs. All right? So to create a graph, or to create a scatter plot, you actually want to quit out of stat. Now that the numbers are all in there, we don't need to mess with that anymore. So you can second, quit, and that'll get you back to the home screen again. Okay. And then notice right above the y equals button, it says stat plot. Okay. That's what we want. That's going to set up making a scatter plot here. So second, stat plot. Okay. Make sure you hit the second first because it's in the blue. All right. And then your plots might be turned on, they might be turned off, mine are turned off. There might be some other kind of graph. Mine are histograms right now. I want to change those. So if you hit enter, go into plot 1, and we can start changing some things up here. Okay. So first of all, we want to turn it on. So make sure you hit enter, and the on is highlighted. And then if you arrow up and down, you can go through all the rest of the stuff here. Okay, so the type. Which one of these do you suppose I want on the type? Which one looks like a scatter plot? First one. Okay. So I want a scatter plot. And then it's going to ask for the X list and the Y list. Okay. So what that means is when you do a scatter plot, you have an X-axis and a Y-axis on your graph, right? So what data do you want to go where? Do you want the time on the X and the minimum wage on the Y? Or do you want the time on the Y and the minimum wage on the X? Which way do you think makes the most sense? Time on the X. Usually time is going to be your X variable. Yeah. So where did we put the time in? What list was it? L1, 2, or 3? L1. So that's set up the way we want it, right? X list is your L1. Time is going to be on the X. And L2 was the minimum wage, so that's going to be on the Y. So we aren't going to change that at all. That's just the way we want it. Does anybody have that showing something different, though? Should default to that. So, okay, good. And then the mark is just, what do you want your dot to look like? Okay, when it graphs it. I like the boxes because they're easier to see. If it's just one little pixel, sometimes it's hard to pick out. Otherwise, you can make the little plus signs too if you want. It's just up to you, whatever you feel like makes the most sense. The reason they have some different ones there is if you do two scatter plots on top of each other, then you can tell which one is which. Okay? So, but I'm going to stick with the box for this one because, like I said, I think that's easier to see. So this is all set. We can second quit out of there. Okay? So far, two things that we've done. We put the data in. We've created the stat plot. Now we need to actually graph the thing. So first thing you want to double check, because it'll yell at you sometimes, is to make sure if you have anything in your y equals that's all cleared out of there. Okay, so I'm going to get rid of that. And then once that's cleared out, we're going to double check that our window is the right size so that we can see everything. Okay, so that's going to be the third step here, is to go into window. And you have your X min, X max, X scale, Y min, Y max, and Y scale. So let's think about it. X was measuring what? What part of the data was X? Time. What numbers did you actually put in for time? 55 to 105, right? So think about X min and max. What would make sense for your X minimum and your X maximum? Yeah, maybe go just a little ways either way. Okay, so 50 would be probably a good min. A max, yeah, maybe 110, a little above. The scale, what do you want to count by? So if it has the little tick marks on the x-axis on the bottom, what do you want it to count by? What do you think would be good? It went up by 5, so if you make the x scale 5, that would make sense. Okay, now the y was minimum wage. So looking at those numbers, what do you think would make sense for min and max and scale and all of that for that one? 0 to 6 seems reasonable, yeah. And then the scale. I might just leave it at 1, right? Goes up $1 every time, so you can kind of see in between where it's at that way. And then the X res at the bottom, that's resolution, and don't worry about that. Just leave that as a 1, and that's fine. Okay, then you should be able to just hit graph and see your scatter plot. Okay, so everybody's got something that looks kind of like mine there? Okay, so here's what we're going to do. We're going to make a second scatter plot, put it on top of this one, but it's going to be the purchasing power one. Okay, so what we're going to do, the data's already in there. We don't need to go back and do that, but we do need to create another stat plot. Okay, so go down to plot 2. Okay, and what I'd like you to do is set up this one the same way we did the last one, but this time make the mark the plus sign instead of the box, or at least something different from the first one that you did, whatever it was. And then see if what I'm doing here matches what you did when you're all done. Oh, you might need some help with this, though. I forgot about that. Your X list should be the same, right? L1, time. That's no different. But your Y list needs to change to L3 instead of L2, right, this time? How do you get that to change? Well, if you look at the bottom of your calculator, and I'll zoom it in here real quick for you because it's kind of dark, hard to see. So I don't know if you guys can see that, but do you see where it's got the little L1, L2, L3, L4, all in there? Okay, that's where you go grab them. Okay, so if you want to put in an L3, you'd have to go second, 3, and that'll put L3 in there for you. So back up here, where I've got Y list is L3, that's how you go get L3 to change that. Okay? Back that up a little bit. All right, and then remember, we're going to do the little plus sign this time. So, the window should still be good. The purchasing power, oh, it does go a little above 6, doesn't it? So we're going to have to adjust what then? The Y max, right? Yeah. So if we go back into our window, let's adjust that a little bit. So Y max, put it up to 7. Yeah, 7 will work. Okay. Go back to graph. Boom. There's the purchasing power with our minimum wage. Okay. So anybody not to this point or need help? Yeah.
At that point, make it the graph. Or is that just...
I can't without resetting your calculator.
All right.
So
do you think it'll matter at all?
mm-mm.
All right.
You just can't see the x-axis, so that'll might make things a little bit more difficult. But I mean, if you just remember that every one of these is 5 years, starting at 55, then you should be fine. Yeah. But later on, once we're done with this, I'll fix that for you. So looking at the graphs, let's see if we can answer some questions. Okay, I'm going to remove the calculator from up here, but be looking at your own as we move ahead here and see if you can answer these questions. So the first one is, in what year did the worker enjoy the highest purchasing power? Now that one you might be able to just get off the table too. This one is kind of an easy question that way. But what year was it? When was the purchasing power the best? Yeah. 1970. Mm-hmm. So what does that tell us? And this is getting more into maybe like less math, more social stuff. But if the purchasing power in 1970 was the best, and based on what you know about purchasing power, what does that tell you? Yeah, the country in general was more wealthy. People earning minimum wage could get more with their money in 1970 compared to any other time. Yep. Okay. When did the minimum wage increase the most? So between what period? Okay. So for this one, you could look at the table and try and answer this question, or if you want to look at the graph and see if you can get the answer from there, you could do that as well. But between what 5-year period do we see the biggest jump in the minimum wage? Okay, so between what 2 years? Or, yeah, between what 5? Yeah, from 1975 to 1980. Okay. Okay, so on the table, you know, if you just did some quick calculations in your head, you just think how much did it go up, how much did it go up, how much did it go up. This went up a whole $1. between those 5 years, and we didn't have an increase like that anywhere else. Okay, nothing quite that big. Also, if you were looking at the graph, okay, can you pinpoint on the graph where 1975 and 1980 are? Where do you see the biggest increase there? It's right here, right? Between these two. 55, 60, 65, 70, 75. See how we get the biggest leap up is between those two. Okay? So that's represented on the graph too. And that. Okay, the other questions I'm going to ask you are a little bit more general, and this is going to be a lot more just from what you're seeing on the graph. So, describe the trend data for the purchasing power. So, again, this is the one that's a little less precise, but just kind of in your own words, what can you tell me about what you see in the purchasing power? What conclusions can you make based on the shape of the graph or the numbers you're seeing in the table? Oops. So that's going to be the little plus sign guys. Okay? So what's going on over time with the purchasing power? So it had that peak up at, what, 1970 we said, right? So as soon as we got just past 1970 into 1975, then we started to see a decrease. Okay? And it had a little bump up in, what was that, 2000? Okay? And then it started to come back down again. Okay? So it's had, kind of in general though, the purchasing power was increasing until around 1970, and then it's been on a decline since then. Okay? Say something to that effect. Okay, something like that. Doesn't have to be anything complex. Just, can you give me a basic description of what you see? Okay, then the other thing we're going to do with this stuff is we're going to go to the third type of modeling, and that's the algebra. So can we actually create equations for this stuff? Okay, for the minimum wage, for the purchasing power. So we're going to let the calculators do that for us as well. You guys did a little bit of this in Algebra 2 with lines of best fit. Okay, so what we have to do, though, is we have to decide, is it going to be a line or is it going to be something different? Because there's lots of different types of equations we could have our calculator produce for us. So if we look at the sets of data here, we've got minimum wage, we've got purchasing power. Just based on the shape of it, what kind of an equation do you think the minimum wage would fit into? What kind of a shape does it have? Yeah, there's an ever so slight curve, so maybe something with a curve to it, but a line wouldn't be bad though, right? It's pretty consistent in the way that it's going up. So we're going to do a linear equation for the minimum wage. What about the purchasing power though? What does that kind of sort of look like? Looks like it might be some kind of a trig thing. It's kind of coming back a little bit. That's true. It has this big bump up and then this little bump over there. Okay. Now, because this other little bump at the end is so much smaller than the first one, though, let's just kind of ignore that. And let's just say, what if it's just a big upside-down curve like that? What does that look like? Parabola. Okay. The other reason that I'm doing it is because a trig function with this is going to be really complex. So I don't want to do that. But So we're going to do a linear for the minimum wage, and we'll do a parabola. We'll do a quadratic for the purchasing power. Okay? So the way that we do that, go back into stat. And we're not going to edit this time. We're going to calculate something. So we're going to go over to calc. All right. And then underneath here, once you get past these first three, these all say there's lin reg, quad reg, cubic reg, and you can keep going down the list, and there's a whole bunch of them. Okay? So these are what we call regressions. It's the fancy word for it. But basically, a regression is another word for of best fit. So it's a line of best fit is number 4. A quadratic of best fit is number 5. A cubic function of best fit is number 6. And on and on and on. Okay? So we want to do a linear regression for L1 and L2, right? If you don't give it anything else after this, it automatically assumes L1 and L2. Okay? But if you wanted, because we're going to need it later, you can do L1 comma, find the comma is just above the 7, and then L2. So it'd be second 1, comma, second 2. If you type it in like that, it'll give you the same thing as if you didn't put the little L's in there, but we'll use them for the next one, so it's good to practice anyway. You don't have a comma? Some of the newer calculators operate a little differently, but in general, that's how it should look. Okay, good. Then your X list and your Y list, L1, L2. That's how you want to do it. Yeah, the newer ones, it pops up a little menu. Yeah, and it says X list, Y list. Then you're going to go L1, L2 for those two. Yeah, if that's the way it looks. In any event, when you hit enter, should get something like this. Numbers on yours should look like mine. And notice how it gives you the equation up here, but then it gives you values for A and B. So if I was going to actually write down an equation for the minimum wage, steal those numbers. Now you can round them off. Okay, you don't have to go crazy with it. But just steal those numbers and write out the equations. So for the minimum wage, it would be Y equals 0.09. I'll take it out 4 decimal places. That's usually pretty safe, but I wouldn't go any further than that. And then minus 4.8818. Okay. And for that one, Y represents years after 1900, because remember we used 55 for 1955, and we used 60 for 1960, and all of that. So that's years after 1900, and then X would be, oh, I'm sorry, this is X. That's X. And then Y would be the minimum wage. Okay, so we've got an equation for it now that we stole from our calculator. Because it appeared to be a line, so if it continues that trend, actually it's a line that's going down, right? That should not have been, that's weird. It actually gave it a positive slope even though, oh, no, that makes sense. It's minimum wage. I'm sorry, I'm thinking myself into the next one. Okay, so we said that we know the minimum wage today, right, is $8.15. So we could check that out, see if it fits the pattern. Okay, how could we do that? If 2014 gives us $8.15, yeah. Right. 2014 is 114 years after 1900. So if we plug in a 114, is it getting close to $8.15 or not? We can check that out. Okay. So we did Y equals 0.0968 times 114 minus 4.8818. So did anybody try that already? It's 615. Okay. So what does that tell you about the minimum wage today?
It's increased more than it has.
Right. we're seeing a greater increase in the minimum wage recently than what was historically happening. Yeah.
Another reason for the big difference could be that the top list could be running off of federal minimum wage, and then the bottom is state.
Oh, what is the federal? Is it like it's still 7 something, I think. Something like that. Okay. So even if we did do federal, then if it's 7.25 or whatever it is, still not as drastic, but still definitely the increase in the minimum wage is more so now than it was. Okay. So maybe if we were to look at the data over a longer period of time, if we had more data, it would look more of a curve as opposed to a line, something like that. Okay. About an equation for the purchasing power, because we said that was looking like it was kind of quadratic, right? So if we go back into stat, go over to which one am I going to want this time? It had kind of a parabola shape to it. Quadrag, right? So we're going to go down to number 5. Now, before you hit enter on this one, though, what 2 lists were we using for the purchasing power? L1 and L3. Okay. So if you got an old school calculator like mine, you got to go down and grab L1, comma L3 for the quadrag. Otherwise, just make sure where it says X list, it's L1, and where it says Y list, it's L3. Okay? And then hit enter on that. And we got this big long thing. Okay? So it's a quadratic equation, though, right? AX squared plus BX plus C. And we've got A, B, and C. We got the numbers to plug in for those. And again, don't go nuts with it. Just decimal places off of each one. 3 or 4 is usually sufficient, and you should have something we can work with. Yeah? Yeah, don't worry about the R. That's a correlation coefficient. We'll talk about that at a later date. But so if we're going to write down this equation for purchasing power, give yourself a little bit of room. So I've got Y equals negative 0. I'm going to go 3 decimal places for each one on this one. 0.002 x squared plus 0.32, if I round it, 3x minus 6.143. So if we follow that one, we could check to see what is the purchasing power today as well, right? Doing the same kind of a thing. If 114 in for X for 2014, what is our purchasing power today? If it's following that same pattern, okay? So if we do that, again, I got to be super tiny here with this. All right, did anybody crunch that out yet? Or shall I? Did we get an answer?
I'm not sure if it's right. I have 2.06.
Okay. That seems reasonable based on the trend we were seeing. Okay. So, what did we notice about the trend of the purchasing power? What was it doing? It was dropping, right? 1970 was living the good life, and then after that, we're not getting so much for our dollars anymore. So today, about $2.06 compared to what was happening in 1996. That seems to make sense from the data. Now, there's going to come a point, though, where this model doesn't make sense anymore, because eventually it's going to do what? It's going to hit 0 and then start going negative, right? And so then a different model is probably going to be better than a quadratic. But for what we had, the window we were looking at, the quadratic seemed to make the most sense. So just some things to kind of think about with that. So that's all stuff we're going to do, okay, with the modeling and that sort of thing. In part of the assignment, you're going to be comparing models from graphs to tables to equations and that sort of thing, and using your calculator to help sift through that. Want to switch gears with the time we got left here and do a little bit of equation solving with you guys. This is going to be more the paper pencil stuff. And then we will quick finish up with some of the calculator work in solving equations if we got some time to do that, which I think we probably will. I can get through this pretty quick. So need to talk about something called the zero product property, which is something you've seen before, but maybe don't remember it. It goes like this. If I multiply two numbers together, and I'm going to call them just A and B. So if A times B equals 0, then that means that one of those two numbers you multiplied together had to be 0. Does that make sense? The only way to get 0 as an answer to a multiplication problem is if one of the two numbers you started with was 0. So this is kind of the basis for how you used factoring to help solve equations. So as an example, if you were trying to solve the equation x squared plus 5x plus 6 equals 0, you can't do it directly, right? But if I factor x squared plus 5x plus 6, then I turn it into a product. Then I turn it into a multiplication problem instead of an addition problem. And then I can use this property to help me solve it. Okay? So, do a little quick factoring review here. We'll do a lot more of this in Chapter 2, but for right now, you guys remember the trick with the trinomials? How you can figure out what the two numbers are you need to factor it? What am I going to need for this one? X plus 2 and x plus 3. Right. What two numbers add to 5, but at the same time multiply to 6? Okay. And now I can use that zero product property to solve it. So since I'm multiplying these two things together, I know that either x plus 2, the first factor, equals 0, or the second factor, x plus 3, equals 0. So what are my two solutions here then? So if x plus 2 equals 0, what's x? Negative 2. And if x plus 3 equals 0, what's x? Negative 3. Good. Okay, so sometimes the trick is going to be just getting it into a multiplication problem. Sometimes it's already going to be a multiplication problem for you. Okay? Like, for example, and it might look a little bit more complicated. Like that. The idea is still the same. Okay? You're still going to use the zero product property to break this thing up into two little problems that you can solve then. Okay? So the first one, 3x plus 2 equals 0. Just a quick couple steps and you're done. What's the solution to that one? Negative 2/3, right? All right, what about this other one? Square root of x minus 1. How do you solve something like that? You can square both sides. Remember, it's algebra. You can do whatever you want to either side as long as it stays the same. So if I square both sides, 0 squared is still just 0. So it's x minus 1 equals 0. And then what's x for that one? 1. Now, the only thing is, with ones like this, if it's got square roots in it and that sort of thing, you do have to double check to see, are there any extraneous solutions? Do you guys remember what that is? What's an extraneous solution? Yeah.
So shouldn't square if you plug in x to one spot, it'll come out to 0?
Not to 0, but it'll come out undefined. It'll be something you can't have, right? So let's double check that, okay? Negative 2/3, okay? I should be able to plug negative 2/3 into both places for x and have it work, okay? So if I plug negative 2/3 in here, I'm good, because this becomes 0, right? What about if I plug it in here? What do I end up with there? You get a square root of a negative number, which is undefined. You can't do it. So this is extraneous. So technically that's not a solution. What about 1? Can I plug a 1 in both places and end up okay still? Plug it in the first one, I get 3 times 1 plus 2, that's 5. Okay, plug it in the other one, I get square root of 1 minus 1, that's 0. 5 times 0, that's 0. Yeah, the 1's okay. That one we can plug in both places. But that negative 2/3 became a problem with the second x, though. Yeah?
You only have to worry about it with the square root?
In this case, yeah. And we'll talk a little bit more about that later in this class when we talk about domain. But, yeah, because looking for extraneous solutions is only going to be, if I plug it in, does it give me something that is undefined? And nothing in 3x plus 2 is going to make it undefined. The square root, yeah, there's going to be some problems there. So really, you're just going to be looking in that one. But so x equals 1 would be your only solution for that one. Okay, so that's using the 0 problem through it, through solving some of those kind of equations. So using the calculator, sometimes you're going to have some equations that you can't factor or you can't solve by hand. And you can use your calculator to help you get through it. So let's say I have the equation I want to solve is something like that. 5x squared plus 3x to the third minus 10 equals 0. Can't factor it, okay? Even with all of our complex factoring techniques that we're going to talk about later on in the class, we wouldn't be able to do it. Can't factor it. So we can graph this equation on the calculator to get to a solution, though. Okay? So what we got to be careful of, though, is when we use our calculator to graph equations, and we've been using it to graph scatter plots, it don't like the two things at the same time. Okay? So you have to turn off the stat plot if you want to do this. Okay? And if you're going to do a stat plot, you have to clear all of these out at the same time. Okay? So you got to get rid of one or the other. You don't have to get rid of the data in there. You're not going to lose all the data that we typed in. But you just have to turn it off. Okay? So here's the other one I was working with. So with mine, if I go into y equals, notice how the plot 1 and 2 are both highlighted. Here's one way you can turn them off. Just right in the y equals menu, go up and hit enter, and that'll turn them off. You can do it that way. Let's say these were still turned on. If you go into stat plot right here, then you can go in and manually turn them off. But then you got to go through this twice and go to each one and turn it off. And it takes a little while, but it can be done. And then you go into y equals and you're ready to roll. Okay? That's what's needed for. Okay? So, I'm going to use a different calculator for this because that one's being a little weird. Okay, so this equation that we're going to look at. Okay. Plus 3x to the third minus 10. We're going to type that in. Okay. We want to know when this is equal to 0. What about the graph is going to tell us when this equation is equal to 0? Yeah. You got it. Exactly. When it crosses the axis. So we're looking for x-intercepts on this. Okay. So right now might be such that we can't see anything, but we can take a look. This is the window that we had, or at least this is the window that I had from before when I used this calculator last. You guys from your stat plots might be something different. Okay? By the way, you should notice it is appearing to cross very near 1, right? Oh, actually, your window, you wouldn't be able to see that, right? Because you started at 55. So let's switch up the window again. So your x min and max if you don't know at all what the thing's going to look like, this is a good home base for functions when you're typing them in. X min at -10, X max at 10, same thing for the Y min and the max. Just make sure you're using the negative button and not the minus button when you type those in, otherwise it's going to yell at you. But that's what's called the standard window. Okay, so if we start at a standard window, hit graph again, okay, we can see that function. Okay, does its quick little turnaround down there, and then it shoots through here. It appears as though the solution to this is 1, but if you plug a 1 into this real quick, you're going to see it's not exactly 1, because 5 times 1 squared is 5, plus 3 times 1 cubed is 3, so 5 plus 3 is 8. 8 minus 10 is actually -2. Okay, so we got to pinpoint that a little bit better. Okay, so first thing you can do, since we know the solution is really close to 1, we can go back and change our window again and make it smaller so we can see it better. So like -2 to 2, -2 to 2 maybe instead, and just look at that. And that'll give you a much clearer picture, and you can see it's like slightly bigger than 1. Okay? So how do we get to exactly where that is? Well, if you go second, and then up here it says calc. So second, calc, we're looking for a 0. So then you go down to 0, hit enter. Just let me know if I'm going too fast here, guys, because this is a lot all at the same time. Okay, and it's going to ask for a left bound and a right bound. So this left bound, there's going to be this little cursor that's like blinking on the function, and you can move it left and right. And you might not be able to see it right away, but if you keep moving it to the right, eventually, as you get closer to 1 for x, you should be able to start seeing it moving up the line there, or up the curve. Okay, so left bound means we want to go just slightly to the left of where we think the 0 is. Okay. So just slightly to the left of it would be like down here then. Okay? So hit enter. And then the right bound, we're going to go just a little to the right of where we think it is, maybe like up there somewhere. Hit enter. And then enter one more time. And now it's going to pinpoint where it's at, which is about 1.098 is the solution. Okay? So if I solve this equation, my solution would be x equals 1.098. Okay? I know there was a lot there, okay? But that process is you graph the function, go to second calc, go to 0, do the left bound, the right bound, enter one more time. Okay? It's on the video that you guys can go get later too. You can watch me do it again if you need to. Okay, but that's the idea. Now, the only other thing that might happen is, what if you use the calculator to solve an equation, but it's not equal to 0? So let's say it's like, I don't know, 6x squared minus the square root of x equals x plus 2 or something. Okay? Well, there's a real simple first step you can take with something like that. If it's not equal to 0, make it equal to 0. How do we make it equal to 0? Move everything off the other side. Okay? So, if I was going to do that, I'd have 6x squared minus the square root of x, subtract the x to the other side, subtract the 2 to the other side, and now I can type that into my calculator. I'm not going to do it, but if you were working on something like this, you could type that into your calculator and then go look for a solution just like we did the last one. Okay? So that's the idea. All right, and I am all done. So I'm going to get you guys your assignment here in just a second.